Okay, gents, just making sure that everything's correct. Just want to talk to you about how to wire up this Genie in the board project. It's pretty similar to the dice project that you've done. It's just we're going to be using these things here, these seals, and the reason we're using these seals is that we can plug components in and we can take them out and we can plug other components in, and so they make the board itself what's called a breakout board. So you can, as I say, you can put things in, take things out very easily. Of course, with these seals, what you have is you have 4 terminals at the bottom. Each terminal is connected to the socket above. And so if I want to connect a wire to this terminal, I just push it into that socket. And so it gets slightly confusing when we're doing this, but I think you should be fine being bright young men. So what are we going to do first? This printout hasn't come out great, I know, but I might have to just have to draw a few things in as we go through. But why don't we start with connecting the high and the low to the high and the low pads. Now the high and the low from the battery, of course, is going to be a cable, and therefore we draw it slightly wiggly. So here we go, there we go, nice wiggly connection. I'm going to be drawing today in black and red. I'm going to be drawing also the tracks of the circuit in red. Now we have this SW1, which is the first component. That is a switch. These are all seals, and these are all those components. We've got a Genie and we've got our info port. With a switch, what you need to do is, the way it works is that when you flick a switch from side to side, it flicks to the left or to the right. When it goes to the left, it means the middle and the left terminal is connected. When you flick it to the right, it means the middle and the right terminal is connected. So the middle one's a common one, which is always connected. So what I want to do is connect that middle one to the high, and I'm going to do that just by going through the terminal next door. Okay, so now I have the high powering the middle switch. So when I flick the switch to the left hand side, I can create a circuit. And where's that going to go? That is going to go down to my high, which is down here. Okay, so that is the high of my Genie, pin 1. Pin 14 is low, and so I'm going to connect that directly to the low. So my Genie now has power. Brilliant. Now that's all well and good, but if I can't program my Genie, then there's not a lot of point it being there. But before we do that, actually, what I'm going to do is do the high and the lows of the circuit. I want to do 2 things. Right, I want to provide power for these push to make switches, and that power is going to be connected to the first and the third terminal of each one of the seals. So what I'm going to do is I'm going to have the power, the high cable, or the high track I should say, sorry, coming all the way down to here. There is 5 inputs on the Genie, D0, D1, D2, D3, D4, and actually we've got 6 pairs of ports here. So that bottom set of ports we don't need. What we're going to do is the first port of the pair is going to be high. So this will be powering the first input, and indeed the third port will be high, and that will be powering the second input. So 2 inputs will be using one of these seals. Equally well, we'll do the same below. Slightly long on that. So that is my input rail going all the way across. I now have to do my high rail. I now have to do my low, which I'm going to do in exactly the same way. Now you remember this whole thing here where you go up and around and down. Done this before on the info port, and that goes over. Right, because we've got a lot of inputs here, we can't have them all going to this low. So I want to put another low on the other side, the top side of the circuit, along with the bottom side of the circuit. How am I going to do that? Well, should have really drawn that in red. never mind. What we're going to do is we'll keep that in. So that's going to go along the low rail. It will stop there, and there'll be a pad there. And it'll go along to about there. All right, cool. And how are we going to connect that? We will connect that with just a piece of cable. All right, so now we've got the high and the low. Right, I'm going to go back to drawing in red because they're the two colors that I have. And my components, I think I might do, I'm just seeing what other ones I've got here. I could probably do in blue, which is quite good. Right, so what's next? These seals here are just high seals, as those are just low. Okay, so all you need to do from each one of the sockets is draw a line going down. And this just provides highs and lows for other boards that we might be using. Okay, really easy. Done that. Right. Equally well, on the right hand side, what we have is the second and fourth socket is going to be low. We're going to use the same housekeeping as we've got here. The first socket is high, second socket is low for that seal. So the second socket over here is going to be low as well, just so we know what's going on. Now we have 6 outputs, Q0 to Q5, okay, and so we're going to use all of the seals on the right hand side, as in every single one of the sockets. Good. Right, now we're in a place where we can start to look at the information port. Information port, we know that the terminal on the right hand side goes low, so just to emphasize that, I'm going to put that going low. We know that the middle one goes to the status. Status is pin 13, so it's this one here. I'm going to try and draw, that's all right. Okay, that's going to therefore link up, and then we've got the programming port, which will be going down here. Now that is going to be connected to the left hand terminals or pads through a 22k resistor, and also through, we need a 100k resistor going low. So what I'm going to do is over here I'm going to draw the 100k resistor, and here I'm going to draw the 22k resistor. So we need to connect the 22k then connects to, so what we've got is we've got the 22k limiting the current, but if we get any floating voltage, that 100k, I'm just going to do it in this, will then go low. Okay, so that is 100k going. That will be pulling down any of that floating voltage to the low side of the circuit. Excellent. What's next? Next up, what we're going to do is, I'm just trying to remember what to do here. We're going to do D4 and D5. And the way we're going to do that is, if you imagine that, yeah, I'm going to connect that terminal to effectively that port there, I suppose. And the second terminal, which will be this one, is going to be connected to my button. So we can see that my push to make is getting a high, given that the switch is switched on, SW1 is switched on. When I press that, electricity is going to go through the switch, back down, and very simply, all I'm going to do is connect that to my port. And so I've got my low will be going into that port via a wire, and then the terminal on the end would be soldered onto a track which is going directly into the Genie. All right, and I'm going to do exactly the same just below it. but of course the difference is it's another switch which is attached to that second half of the sill. Okay, so that sill is for two different inputs. The different inputs are these different push to makes. The push to makes are connected to the Genie. One thing that we haven't done, and that is that we need to connect, thinking of the best way to do this. We've got a 100k resistor, and to be honest with you, it's a bit close. So I'm going to draw the resistor really quite small, but we've got another resistor there, so that is 100k, and that is 100k. And this would be repeated, of course, for each one of these push to make switches, and each one of these push to make switches would be connected to one of these inputs. Now the difference being for the next ones is that we need to that one be going there, that one be going there, and that final one would be going there. But the pull downs for these would be located here, and the reason for that is it would be just too congested if it was on the other side of the circuit. So we've got our pull downs. Where the pull downs need to go, they need to go to the lower of the circuit. I've drawn it in black because that's the language that we're using. So now we've got the pull downs for each one of these inputs. Excellent. We've got our current limiting and we've got our pull down for the programming pin. Status doesn't need anything apart from being connected. The only thing we're left to do really is the outputs, and the outputs are really easy. The outputs are just straight. So the outputs on this, we've got 6 outputs. So and of course, you must remember these are tracks, not wires. It is getting a little bit confusing given this drawing is not very clear. But it'll be something like that, yeah. Each one is connected to one of the seals, so one of the bottom pins of the seals. And then what we can do is we can plug different things in. Now what we have on this is these LEDs. These LEDs, for example, as long as we do it correctly, if we have a long leg, and I'm just going to show you that there will be a long leg, and I imagine the long leg is on the left-hand side. That's how I usually draw it. The long leg then, will be connected to there, and then the shorter leg would be plugged into there. So then when that pin, which is Q0, goes high, the LED illuminates. One thing I will say is that these seals are all very good, but notoriously that cables come out and people don't realise it. So when we actually make the final product, what we often do is produce some pads. And so what I would suggest is for every input, and it's much better if you do this in a line, to be honest with you, you just have a pad that once everything has been decided, you just connect it, you hard connect it. But for this, all intents and purposes, and it's the same here actually, you do exactly the same. But that is our circuit. So I hope that, well, our circuit as in, you've got to finish off doing this, and you've got to finish off doing that as well. But apart from that, everything is on the circuit, and you can tidy it up and go forward. I hope that helps. All right.